Hello and welcome to the application number 7 walkthrough for our integrated math 1 through upward bound. Today I want to look at some of the application problems and give you a little bit of insight on how they should be completed and really what's the best way to get there. For the first set of problems here, we notice that they want us to find the missing coordinate and they're giving us the slope. The key here is that we have to remember our slope formula. So y2 minus y1 over x2 minus x1. And we're going to treat this like we're really starting every problem here like we're finding the slope. But instead of finding the slope, again, they're giving us the slope. So we're going to use that to then find, I think all these are going to be y coordinates that we're going to find. So that's probably going to make life a little bit easier. Okay, so let's go ahead and get started here. On the first one, my slope is 2. So I'm going to say 2 instead of m equals. I still have to do the same thing if I want to label out my x1, y1, x2, y2, I still have to keep everything in the same order. So y2 minus y1 is going to be 5 minus y over x2 minus x1, 4 minus 2. And really what this is this is just an equation. It's probably a two-step equation with a little bit of simplifying that needs to happen first. And then yeah, it's a two-step equation, and let's go ahead and see how we might do that. So 2 is going to equal still the 5 minus y. I can simplify the 4 minus 2, though. 4 minus 2 is just 2. So in order to solve this, I'm going to multiply both sides, not subtract, multiply both sides by 2. And 2 times 2 is 4. Over here, my 2's cancel out. That's what I want. So 4 is going to equal 5 minus y. Okay. Next thing I can do is subtract 5 from both sides. Subtracting 5 is going to give me negative 1 equals negative y. And again, what does that mean when a negative equals a negative variable? One thing I can do is divide by negative 1 on both sides, or just know that if negative y equals negative y equals negative 1, then y has to equal positive 1. And the more you do this, you might see some tricks that would make these a little bit easier. I'm going to go ahead and show you that trick. I'm going to do the third one, showing you that trick. It's really going to look the same as kind of how I did this one. But I'm going to make sure of one thing. Since I know that my y2 is I'm not subtracting that. Notice I'm subtracting the y1, and that gave me that negative y at the end. I want to make sure if I have a variable, it's going to go into that first spot. So I'm going to make sure that this is y2. Okay? And knowing what one of those is kind of makes the rest of them fall in line. This is going to be x2, this is going to be y1, and this will be x1. So really the numbering is just the standard numbering, the same thing I would have done on the first one. On the first one, I would have just made this my y2, x2, x1, y1. And then it would have been a little bit easier. I'm not saying it's a lot easier, but it's a little bit easier. But anyways, the problem is going to go about the same. I'm going to have negative 1/2 for my slope is going to be equal to y2, which is y, minus y1, which is 3, over x2, which is 3, minus x1, which is minus a negative 5. We'll write that as plus 5. So I get negative 1/2 is equal to y minus 3 over 8. And then from this step here, the steps are all the same. Simplify your denominator, multiply by both sides by your denominator, and then subtract or add your constant over. So I'm going to multiply both sides by 8 here. That's going to give me a -4 equals y minus 3. And then I'll add 3 to both sides to get y equals, again, or no, this time it's a -1. Last time it was +1. But so that's just the idea in those problems. You're using your slope, they're giving you slope, and you have to find one of the coordinates, which is a good skill to be able to accomplish. In the next problem here, it says you're parachuting. At time t equals 0 seconds, you open up your chute at a height of 2,500 feet above the ground. So that's this right here. They're showing us that 0, 2,500. I think something that might also get a little bit interesting is this actually gives us our y-intercept. Okay, that gives us our y-intercept. At time t equals 35 seconds, you're at a height of 2,115. So you're right down here. They're just giving us this other point in the problem, but you can really realistically do it all from the graph. What is your rate of change in height? Okay, rate of change is how fast does our height change. You know, in a sense, we're looking at, I know that over 35 seconds, you know, I dropped somewhere around 400 feet, almost 400 feet. So that's over 35 seconds. But what about if I just wanted to know over 1 second? Well, the way I do that, the rate of change in graphing terms is your slope. Okay, so the rate of change is the slope. And so what I want to do is I want to find my slope using the 2 points that I have. Let's make these ones my 2's and these ones my 1's. So I'm going to go my y values. And then my x values. 35 seconds minus 0 seconds. And then it might be beneficial to have a calculator for this. Let's go to 115 minus 2,500, and then divided by 35. So it gives us a slope of -11. That means for every 1 second, we drop 11 feet. Okay, that one wouldn't make sense to be a positive slope because the parachute's going to slow us down, but realistically, it's not going to take us higher in the air unless there was some crazy wind, I guess we were dealing with. But I'm going to leave it to you to try to figure out when are we actually going to hit the ground. One thing I will tell you is, which you can figure out just as easily as I can, the equation for this, which, well, I guess we haven't really written equations yet, but you will tomorrow, or Wednesday. The equation for this line is y equals mx plus b. I have my slope. This, again, is my y-intercept. I alluded to that earlier. So I'm going to say that this can help. I'm not going to give any more hints other than what does it mean to hit the ground? What variable is affected? Well, technically both variables are affected, but what variable do you know if you hit the ground? I'm going to leave it at that. What variable whose value you would know hit the ground if my y is height and my x is time? Okay, I'm going to leave it to you to figure that out. But I think that equation can help. Another thing that could help is that, you know, at 35 seconds, you're at 21:15, and you go down 11 every time. You go every second. So at 36 seconds, you're at 2,104. Now this could take a while, but it would get you to an answer. Okay? So feel free to give that problem a shot. If you have any questions, you can definitely let me know. It says here that Mr. Gall's never heard of an unlimited text plan for a cell phone. So I have a plan that charges $37 a month as a monthly fee, plus 15 cents for every text that I send. Okay. Here it says, write an equation for my monthly bill, letting y be how much money I have to pay, and x be the number of text messages I sent last month. So you want to know what is your slope and what is your y-intercept. That's the hint there. And I guess we can go ahead and talk about it. What this means is, if I don't, and what we kind of have to think about, if I send no text messages in a month, how much money will I owe at the end of the month? Well, hopefully we see that it's going to be that $37. They're going to charge me that $37 every month, no matter what, whether that's a service fee or insurance or whatever it is. That's my base charge, $37. So my y-intercept is $37. What is my slope? Well, slope is how much it changes. And the only thing that changes this cell phone plan, apparently, is the number of text messages I send every month. And it's going to go up by 15 cents. So the equation that I would write, since we haven't really talked about writing equations yet, I'm going to help you with that. I don't know why I wrote 0. I know that my y-intercept, so my b, is going to be $37. And then I know that it changes 15 cents per text. Now, does that mean that I have 15x plus 37? Well, let's think about that. Say I sent one text message in a month. Okay, only one. That's a pretty lonely month. But does that mean they're going to charge me for one text message, $52? 15 plus 37? And no, it doesn't. It's actually 15 cents that we have to write as 0.15x. Okay, so that's actually the equation that would model how much money I have to pay. Okay, I'm going to leave the rest of them to you. B and C involve plugging numbers in. The important thing to know about this equation are what these variables stand for. Okay, what the variables stand for, x is being multiplied by 0.15, and what's that relating to? That's relating to text messages sent. So this is the number of texts sent. Now, typically, this isn't the case even in an unlimited or in a limited text plan. Usually, it's sent and received. I'm just worried about sent for this problem. And then y is going to be the cost. So B involves plugging a number in for, says use your equation to find out how much I would have to pay if I sent 28 text messages. So for B, you would have to plug 28 in for X and figure out the cost. For C, you're actually going to plug a number in for Y for the cost, and then have to figure out how many text messages were sent. That one's a little bit harder. There's a little solving equations that you're going to have to do. But I'm going to leave you with it right there. I feel like I definitely helped out quite a bit on a lot of these problems. But feel free, if you have any questions, put them down below in the comments, and I will get to them as soon as I can. Good luck, and we'll see you in class.